In the world of nuclear science, there are few things as terrifying or as weirdly named as the blue flash. It's the telltale sign that something has gone horribly wrong, a criticality accident. They're rare, they're incredibly dangerous, and the story of how we learn to even try and control them, well, it's a story written in tragedy. You know, the physicist Richard Feynman, he just absolutely nailed it with this quote. He perfectly captured the sheer audacity, the sheer danger of those early days at Los Alamos. These scientists were pushing the absolute edge of what was known, working with materials so powerful that one tiny slip-up wasn't just a bad day at the lab, it was instantly fatal. They were, quite literally, tickling a dragon's tail. So what exactly is criticality? Okay, think of it like the ultimate tipping point. It's that precise moment when a nuclear chain reaction can just go off on its own, sustaining itself. Now, that's a state you want if you're building a nuclear reactor or weapon, but when it happens by accident in a lab, yeah, that's an absolute catastrophe. To really understand these accidents, we have to zoom in and talk about one specific infamous object, a 14-pound sphere of plutonium that would go on to earn the chilling nickname, the Demon Core. Yeah, this one single piece of plutonium was at the center of 2 fatal accidents in less than a year. The story of Harry Daghlian and Louis Slotin is just this incredible, awful tale of brilliant minds, immense pressure, and the completely unforgiving laws of physics. So this first accident, it just shows you how stunningly hands-on this work was. The physicist Harry Daghlian was working all alone, literally stacking these heavy tungsten carbide bricks by hand around the core. Now these bricks, they act like mirrors for neutrons. And as he was placing the very last one, he dropped it. It fell right onto the assembly. And boom, instantly enough neutrons were reflected back into the core to trigger that runaway reaction. In that split second, he received a lethal dose of radiation. The dragon was awake. And here's the part that's just hard to wrap your head around. Only 9 months went by before another physicist, Louis Slotin, was setting up a similar demonstration with the exact same piece of plutonium. And this time, there was an audience. We actually have an eyewitness account from a security guard who was there, Patrick Cleary, and his description of the moment is just bone-chilling. He saw a blue light. There it is, the blue flash, and then he felt a physical wave of intense heat. Can you imagine? Everyone in that room knew, in that very instant, that something had gone terribly, terribly wrong. And what's wild is that they had equipment to do this kind of thing safely. I mean, look at this. This machine, called the honeycomb, it was designed to bring the 2 halves of an assembly together with precision, all controlled from a safe distance. But for his demonstration, for some reason, Slotin chose to rely on his own hands. The setup itself was just unbelievably precarious. Slotin was using a simple flathead screwdriver, and that's it, to keep 2 halves of a beryllium shell separated from the core, and that shell is a really powerful neutron reflector. So as he's working, the screwdriver slips, just by a fraction of an inch. The shell drops, encases the core, and immediately reflects its own neutrons back onto itself. It goes critical. In what you can only describe as a final heroic act, Slotin tore the assembly apart with his bare hands, taking the brunt of the radiation. He saved the other people in the room, but he sealed his own fate. And as if the story wasn't tragic enough, the details are just haunting. Both accidents happened on the 21st of the month, 9 months apart. And when they took Louis Slotin to the hospital, he was placed in the very same room, the very same hospital bed where his colleague Harry Daghlian had died. So the story of the Demon Core is absolutely terrifying, but it begs the question, right? How does this famous story fit into the bigger picture of these accidents worldwide? Well, let's take a look at the data. So were these early Los Alamos accidents just a product of their time, the Wild West days of nuclear physics? Or do they actually tell us something more fundamental about the risks of handling this stuff? Well, a big review by the Nuclear Regulatory Commission gives us the answer. And what's really fascinating is that the Demon Core accidents, the ones everybody knows about, they're actually the exception. Turns out 21 out of 22 major process accidents involved fissile material in liquid solutions, not solid chunks of metal. The results were horrific, 9 deaths, people losing limbs, but what's remarkable is that almost none of them caused any significant contamination outside the actual facility itself. So this is what the more typical setting for a criticality accident looks like. Big industrial tanks filled with radioactive solutions. It's a whole different world from one scientist in a lab with a screwdriver. In this kind of setting, a simple mistake, turning the wrong valve, a miscalculation in the concentration, could lead to disaster on a much, much larger scale. But these tragedies, they weren't in vain. Every single one of them provided a critical, hard-won lesson that fundamentally changed how nuclear materials are handled, even today. And the contrast between then and now is just stark. Directly because of the Demon Core accidents, any kind of manual manipulation was replaced by remote controls. Because Daghlian was working by himself, the two-person rule was created. Instead of just relying on a person's steady hand, engineers now design favorable geometry, basically containers that are physically shaped so they can't go critical. And maybe the biggest change of all, alarms were installed to give that immediate warning, the one thing the people in that room with Louis Slotin never had. But as you can see from this table, the risk never truly goes away. Accidents have continued to happen all over the world: Russia, the UK, and as recently as 1999 in Tokaimura, Japan. And get this, 2 workers died there after mixing a highly enriched uranium solution in, of all things, a stainless steel bucket. Human error is always there. But let's circle back to our main character in this story. Whatever happened to that one specific object? What was the final fate of the Demon Core? For decades, the myth was that the core was just too cursed, so they detonated it in a nuclear test at Bikini Atoll. You know, a dramatic end for such a notorious object. But recent research revealed the truth is actually way more boring. It was simply melted down, and its plutonium was recycled right back into the US nuclear stockpile. So in a weird way, its atoms are probably still out there, scattered across the arsenal. This whole history, right, from the blue flashes to the split-second errors, it all points to one ultimate lesson: the absolute need for constant, unending vigilance. The conclusion of that big NRC report really says it best. The risk is always going to exist as long as these materials exist. Our only real defense, then, is memory. It's making sure that the sacrifices of Harry Daghlian, Louis Slotin, and all the others are never forgotten. And that leaves us with one final question, doesn't it? Have we truly learned the lesson that was taught by a simple slip of a screwdriver?